So I was in lab just kind of working with a few systems trying to make it work, mixing oil and water basically and putting magnetic particles on there. And it just made this pristine Grecian urn looking thing, and I was just kind of like, what's going on? And yeah, it was just really weird. You know, you have this like pristine urn looking thing and you shake it up and then it comes right back. Usually liquids don't do that. The expectation is that usually particles go to an interface and then you shake it up and you make a bunch of droplets. And then if there is no particles there, the droplets just come back together, and like oil and water, you just get, separated oil and water. Kind of like, salad dressing, you mix it up and then it makes an emulsion. And we got the exact opposite of that. It didn't separate fully. We have this like nice urn shape.
In classes and textbooks, I had learned that that was not possible. And a lot of our discussion was looking at those textbooks and theory and discovering that they had made assumptions that didn't apply to his system.
Everybody, I think, was a little bit confused and was kind of pushing me to just, poke down that path a little bit and see what's going on there.
What Anthony discovered is that when magnetic particles go to a liquid interface, they organize themselves because they're interacting through their magnetic moments. And because they organize themselves, they change the properties of the interface and change the way that the interface is shaped and change the stability of the interface and other features that are really important when we're dealing with liquids.
It's more of a fundamental physics discovery that things can increase interfacial tension and that this leads to this nice Grecian urn shape. Things like that don't happen very often, where you're just sitting in the lab and you mix stuff together and you just find something that completely defies your expectations.